Hi, I'm Adolph Oliver, and this is the video clip on scientific notation calculations. Well, remember again, scientific notation makes it much easier to multiply and divide very large and very small numbers, and we've got some examples here for you. First, to multiply numbers in scientific notation, and here are two scientific notation numbers here, both of them in proper form. Very simple to do. Since these parts are all multiplying each other and multiplication commutes, we can take them in any order we want. So multiply the two plain numbers together. 3 times 1.5 gives me 4.5. And then multiply the powers of 10. And of course we know since the bases are the same, we simply add the exponents. So negative 8 plus 6 is times 10 to the negative 2. Well, notice this one happens to be in proper form. That's not always the case. We'll show you some examples where you've got to correct them. But since it's got one non-zero digit in front of the decimal point, this is in proper form. So there's our final answer. Now, what about if you're dividing these guys? Okay, here comes a division example. We've got 6.6 here times 10 to the negative third divided by 3 times 10 to the 4. Remember, in scientific notation, the x's here are the old multiplication x's. Now, regular scientific notation answers like this one we got up above here, there's no denominator. So this denominator we got to get rid of. It's real simple to do. You just take and divide the numbers. 6.6 divided by 3 gives me 2.2, and that gets rid of the 3. I divided it in upstairs. And then simply take the power of 10 here and jump it upstairs. Whatever it is, positive or negative, we don't want it downstairs. We got to get rid of it from there. So it goes up as 10 to the negative 4. Remember, the exponent changes sign when we jump it across the fraction bar. So 10 to the negative 4 down here, 10 to the positive 4 down here becomes 10 to the negative 4 upstairs. So we've removed this. Now, what are the powers of 10 left here? Well, this is a regular product rule, so we add the exponents. So times 10, negative 3 and negative 4 combines to negative 7. So there we are. And again, this has one non-zero digit in front, so it happens to be in proper form. Okay, well now, let's take a look at some more multiplication examples. And here we go again. Now, remember, scientific notation, since everybody's multiplying everybody here, all we have to do is multiply the two plain numbers together. 7 times 2.2 gives me 15.4. And then do the powers. Okay, this is product rule, so we add them. Times 10 to the 3 plus 4 is 7. But now we got a problem here. This is not in proper scientific notation form. We got 2 digits in front of the decimal point, not 1. Here's the safest way to do this. Concentrate now on the 15.4. What we want to do is have the decimal point between the 1 and the 5. So just convert 15.4 to proper scientific notation form, and we're going to get 1.54 times 10. Now, 15.4 was greater than 1, so the exponent's going to be positive, and we only needed to jump at one place. So this is what our improper form becomes, 1.54 times 10 to the 1. Well, now, of course, don't forget, we add times 10 to the 7 here. So now combine these powers. Let's put the number down first. 1.54 times 10 to the 1 plus 7 times 10 to the 8. So now we've got it in proper form. So if you end up with somebody that has too many places in front or not enough, play this little game. Just turn around and convert it to scientific notation. Then bring down your other power of 10, put it all back together again. Okay, let's see what we're going to have in this next one here. 2.5 times 8.4 is going to give me, let's see what we have here. 8.4 times 2.5. I'm doing a little bit of math off on the side. Looks like it's, let's see, 8 and 1, 6. So I get 0, 0, carry the 1 and 2. I come up with 21 when I do these two. Okay, so here we go. 21.0. Now we're going to have to fix that up in a moment. But let's do the powers now. Times 10 to the 3 and negative 6 would give me negative 3. Well, once again, look at this. We got to do a little doctoring here. It's not in proper form, but that's not difficult to do. Okay, we want to have the decimal point between the 2 and the 1. And this is a big number compared to 1, so it's going to be times 10. It'll be a positive exponent, and we had to move it just one place. Now you can see this is correct. 2.1 times 10 does indeed give you 21. But the reason we did that now is so when we bring down the other power of 10 we had, we can get our final answer. 2.1 times, well, plus 1 and minus 3, 10 to the negative 2. Okay, well, let's take a look at the last one we have here. Some division examples. So let's see what we end up with on these guys here. Okay. Remember again, there's no downstairs in proper scientific notation form, so what we've got to do is get rid of the downstairs. Well, divide the numbers. 4.4 divided by 2 will give you 2.2. Now, we got rid of the 2 by dividing it up. The 10 to the negative 3, we got to get rid of that. We jump it upstairs. Oops, I should say 10 to the positive 3 down here. I was getting ahead of myself. Jumping it upstairs, it becomes 10 to the negative 3. So let's go over this again. We took 4.4 divided by 2. That's where we got the 2.2. Then take the 10 to the positive 3 and jump it upstairs as 10 to the negative 3. We've got to get rid of it downstairs because there's no downstairs in proper scientific notation form. So, okay, what do we end up with upstairs times 10, negative 2, and combine it with negative 3, looks like 10 to the negative 5. Okay, one last guy to work on down here. Once again, what we've got to do is take the numbers first and divide them out. So 5.6 divided by, let's see what we're going to get here. 5.6 divided by 8.4 comes up to be 0.67. Okay, so 0.67, here we go, 0.67 times 10. Well, we divided by the 8, jump the power of 10 upstairs. It goes up as 10 to the negative 8. Remember, we got to get rid of everybody downstairs. We divided the 8.4 into 5.6, but now we also have to get rid of the 10 to the plus 8. Goes up as 10 to the negative 8. So we end up with times 10. Negative 4 and negative 8 is negative 12. Well, look what happened here. we don't quite have this one in proper form, do we? It has got a 0 digit in front. So once again, work on this one on the side. Where we want the decimal point to end up with is between the 6 and the 7. So we'll have 6.7 times 10. But now notice, this number's small compared to 1. So that means our exponent's going to be negative. And we had to jump at just one place. So 6.7 times 10 to the negative 1 gets us in the proper form. Now, don't forget, of course, we had the 10 to the negative 12. So our final answer in proper form is going to be 6.7 times 10. Well, we got negative 1 and negative 12. That's negative 13. Okay, well, this is the basics of how you multiply and divide scientific notation numbers.